All right, so one of the first things you need to do is you need to set up a log file so that you can print off your results later. So let's go to File, go down to Log, and we're going to say Begin. Right? I don't know what that's about. But in this one, it should already have you in your project, the same variable that you were in. So we should be able to go to H project. I'm just going to call this project 3 log, and it will save it as .smcl. That's a Stata log file essentially. So we'll save that. And so log using h colon backslash project 3 log smcl. And later, when we want to print that, we actually have to translate it into a text file. But that'll be one of the last things that we do when we're ready to wrap everything up. Okay, so let's go back, and we did the logit project, and the logit project we did with this dichotomous variable, firefighter injury, and then we included a number of these interacted variables with the number of responders. The problem with that, and I didn't realize it until a little bit later, is that we left the null category completely uncontrolled for, but we should have included the control for the number of responders for that null category, which was IIE and assistance, and then also I think the last one was EMS. And so we needed to have that extra measure in there. So let's go ahead and take a look at what logit would look like for a better specified model. So in Stata, the commands go down here in the command window. If we like, we can make them a little bit bigger. Just raise it a little bit, which is easy. Here, I'm going to go back and do that old variable. Let me go, where was it? Firefighter injury. And you can just click them from the list over here, which is somewhat useful. We'll go FCNR, search and rescue. We didn't do AMS. We did hazard. We did fire rescue hazard. We did systems. We didn't do assistance. We didn't do IIE. They were the null. And the last one was that standby. And so after that, we need to, because each one of those is interacted with, this is the dependent variable. These are the independent variables that are interacted with number of responders. Let's go ahead and put that number of responders in there as well. Okay. We're going to just run that. That's all we did, is just put the logit command in there, the dependent variable first, and then the list of independent variables that you're going to run it on. And let's run that and see what we get back. Here at the end, we got some issues, failure, successes. That's kind of to be expected. There's not a whole lot of injuries are so rare here, so that the predictive ability of the model is not great. One reason why we're going to go to the event count. But as we see here, the nice thing about this is number of responders is negative, right? And then these increase, these parameters go back to kind of expectations. So what we saw in that last probability plot is we saw some more risky activity for fire control versus the other when you actually did plotted the residuals. And with this model specification, you kind of see that, right? Fire control was the most risky. It had the largest positive value. So each firefighter that you have in the response for a fire control unit adds about 0.15, whatever the translation is into log odds, which is pretty close to 1.5. Each adds 1.5. Search and rescue, every additional one only adds 0.07, and then FRH is about 0.06, and all those are significant at high levels, right? So, and of course, number of responders is as well. So it's actually a slightly negative trend, and then these are slightly positive. So it kind of works out. That's essentially what we should have done the first time. One nice thing that you can do on the back side of this, and we'll be doing it, is once you run an estimation, it's nice to take a look at the post-estimation commands. And so here you can run what's called fitstat, and it'll give you the log likelihood. These are the AIC values down here that we're going to be using to diagnose models, and so that's fairly useful. Okay, so that was the old model that we did. For this one, we're going to do actually something a little bit different. Because we're going to have to do this zero inflated model, we have to actually specify a specification that's going to predict whether it was a zero event or a greater than one event. And so that zero inflated essentially ties a logit model to the event count, to a negative binomial event count. And so it's sort of a two engaged models doing the same estimation. So what we're going to do is, let's quickly go back and do logit, but we're going to do for the variables that we're working with, the independent variables we're going to be working with now. In your command window, if you click in there, I think if you're on a regular, if you hit page up, it'll take you back up into the previous one. If you're on an Apple, you have to actually do function arrow up. And so up here I had firefighter injury, and I'm going to get rid of all of these NRs on the back of those, right? Because we're going to just go back to the original dichotomous variables. And then we're going to keep that n responders in. So let's take a look at this, and then we'll run fitstat and we'll compare the two models. And this is what we're going to do. We're going to run with we're actually going to change this to the event count, but we're going to run with dichotomous independent variables and then a continuous variable for the number of responders. Yeah, let's run that and let's see which model will look better at the end. I'm going to run fitstat again. And so let's see, AIC by Stata 744 is that one, right? And we want to minimize the AIC value, and that one was 822.15. So that's a pretty big increase, and so essentially we probably should have done dichotomous in the first place. I was trying to avoid one particular problem, and we got a slightly less effective model because of it, but that's okay. We live to learn. So this tells us that we've got a reasonably, it's an okay model. It probably doesn't predict any, but have any predictive value. But we're going to essentially take this in, and we're going to get rid of that dichotomous variable, and we're going to work with the new event count. Okay, good. Okay, so we took a look quickly at the logit models, and now what we're going to do is we're going to go and try to do the event count models. I'm going to show you how to do it with the menu driven estimates first, and then I'll show you how to just, we can convert that into the next one, which is negative binomial. But let's click up here for statistics. You'll see they have different variables by binary outcomes. So if you go in there, you get logit, right? Logit, risk, probit, and all those other ones. If we go to ordinal, you'll do ordered logit and that kind of stuff. But we're interested in these count outcomes. And so let's do the Poisson regression, and let's do the first dependent variable. We're not going to do this firefighter injury one anymore, right? We're not doing that. That one's dichotomous. We're actually going to go up, and we're going to use that original continuous measure, right? Over here, we can select our range of variables, and we just did the last ones, right? So let's go this one. We're going to do FC, SNR, hazard, FRH, SNS, and FSO, and then add number of responders. That's good. We don't need anything there. We don't need any constraints there yet. We're going to do something very simple. We don't need weights. Sometimes you'll want to use robust standard errors, but eventually we're going to, so you could click on this and do robust if you wanted. I'm going to use the defaults because we're going to do a little bit of work with the zero inflated, and it doesn't like the robust immediately. We can check the robust afterwards, and so we'll look at that later. Maximization, those are all good, and so if we click here, we should in this command window see something pop up, and it'll run that Poisson model for us. Okay, so it went out there and it ran. Let's take a look. The other thing I want to do, let's go out to statistics, and I want to run this count outcomes. I want to run goodness of fit after Poisson, and I'm interested in this deviant statistic or the Pearson goodness of fit test, right? So let's check on that. All right, goodness of fit, probability greater than 1. Okay, that's okay. Let me check statistics, count outcomes, goodness, summarize, estimation, sample, VC, bootstrap, Pearson, goodness, Diva, statistics. I guess that's okay. Let's run fitstat. 1, we'll see here we've got an AIC of 1084. That's going to be a baseline for this model. One thing here, and we'll find out as we go forward, that this particular Poisson isn't very good. Remember, one thing with Poisson is you have to have the deviance has to equal to the mean of the dependent variable, and in this case it really doesn't. If you I don't know how to express it here, but when I ran it in SPSS, it wasn't equal to 1. So what we'll do is we'll end up running a negative binomial, and then we'll run a zero inflated after this. But I think we're getting a little bit long on time, so I'm going to stop there.